Okay, looking at Electrochem quick check 1. Right, so we're looking at Electrochem 2, quick check 1. We have the electrolysis of acrylonitrile. Importantly, they say dissolve in an alkaline medium. Okay, so in this case, what are the species present? You have, of course, acrylonitrile. Because it's an alkaline medium, you also have your OH minus as well as your H2O. Okay, in this case, the question was well guided. It says that this is the reaction at the cathode. So recall cathode is your reduction. And in this case, it's quite obvious. The 2 electrons are on the left-hand side. So it's a reduction. Alright, reduction is gain of electrons. The question then go on to say that anode, you produce oxygen. So oxygen, O2, right? Recall, anode is oxidation. So in this case, what are the species present at the anode? At the anode, you have your OH minus as well as your H2O. So we are supposed to construct an equation for the overall reaction. The cathode equation, of course, we know that's given in the question. We now need to determine whether hydroxide will undergo oxidation at anode or water will undergo oxidation at anode. Since we are looking at oxidation, we should be looking on the right hand side of the data booklet. So looking at the data booklet, these are 2 equations. You can see that both H2O and hydroxides, in this case, it is the oxygen in both species that's oxidized to O2. Okay, so we're looking at the oxidation process. So when we take a quick look at the E0, because we are looking at oxidation, alright, the less positive species will undergo preferential oxidation, and that's why your hydroxide will undergo oxidation at the anode to form O2. Okay, so this will be the equation for OH minus to form O2, 2H2O, and 4 electrons. So this is the anode equation. Now, once we have these 2 half equations, take note again, equations are written with a single arrow because we have already determined the directions of the reaction. So single arrow, single arrow. Okay. To come out with the overall equation, we look at the electron ratio, 2 electrons and 4 electrons. That's why I need times 2 to the cathode reaction. And then I sum the species up. Okay, you can pause the video now to check your answers. Okay, moving on. We are supposed to calculate the volume of oxygen when 0.01 mole of acrylonitrile is electrolyzed. So in this case, there is no information on the current or neither the time. So therefore, using your formula of N equals to IT over NEF is not valid. Okay, so because we do not have any value on current. But what we do have is the mole ratio of the acrylonitrile to that of O2. Okay, so 4 moles of acrylonitrile will produce 1 mole of O2. So we know that 0.01 mole of acrylonitrile is electrolyzed, so the O2 will be 0.01 divided by 4, and therefore I get 0.0025 moles, and therefore based on the question they said RTP, the molar volume it's at 24 dm cube per mole, so you multiply by that you get 0.06 dm cube. Okay, moving on to C, last part. Now we have the current 8 ampere and then pass through 100 minutes. The question now wants you to electrolyze acrylonitrile, and in this case we're using inert electrodes. We're supposed to calculate the mass of acrylonitrile used up. So acrylonitrile is basically the reaction at the cathode. Every 2 moles of acrylonitrile, you need 2 moles of electrons. So the ratio of acrylonitrile to the electrons is 1:1. Okay, so in this case, we can apply our formula, IT over NEF. I will be 8 ampere time 100 minutes. I need to convert to seconds. Of course, Faraday we know is a constant, 96. Sorry for the disruption. check. Try to go back. Okay, 96. Five, 0, coulombs per mole. And in this case, as I mentioned earlier on, the mole ratio of alkyl nitrile to electron is 1:1. So Ne will be 1. Okay, substitute the values in. Okay, and this is the number of moles of alkyl nitrile you have. Since the MR is 53, that's the question given to you. So 0.4974 multiplied by the MR, you get the mass, 26.4 grams. Okay, and with that, we are done with quick check of Electrochem Part 2.